This video will go through page 79, question 3. Given as a point on the ellipse P, the eccentricity of the curve is 0.6. Construct a portion of the ellipse to include point P. So this time we're given the directrix, we're given point P, we're not given the focus, we're not given the vertex. So we're going to have to use this formula to figure out. So if I go ECC, which is equals point to the focus over point to the directrix, is 0.6. So 0.6 is the same as 6 over 10, because that's 0.6 as a fraction. We can make this smaller, so that's the same as 3 over 5. So what that's saying is the distance from the point, now it doesn't have to be this point, but it could be any point, has the same ratio. So what they're saying is, as a ratio from the point to wherever the focus is 3, in comparison to the point to the directrix is 5. So what we do is, it'll make more sense when I do it, we join a line straight back from the point to the directrix. So that distance is 5 basically. That's 5 units in terms of a ratio. So I'm going to divide that line into 5. So we use the rule we learned in first, second year. Draw a line out at any angle. Take any distance on your compass. Step it off 5 times. 1, 2, 3, 4, and 5. I'm just going to label that. You join your last point back to the end point on your line. Okay, and if I bring all these back parallel, that will divide my line into 5. I only want to know where the third segment is. So I'm going to bring back number 3. So now, let's put a blue dot. That line is divided into 5, and that ratio there, that's the third unit. So that is 3 is to 5. So I'm going to just take this distance now. So you're taking the distance from your point to number 3. I'm going to rotate it down to where it crosses, and that is going to be my focus. Because that distance there is the same as there. So that is in ratio as 3 is to 5. So we've used our eccentricity line to find our points. So what we need to find now then is our ECC line, and we need to find our vertex. So how do we do that then? We're going to bring a line. We're going to go use this formula again, because like the very first questions, we use this at the start. So I'm going to start again. I'm going to take 6 over 10. I'm going to multiply it by, let's say 10. That is the same as 60 over 100. So what I'm going to do then is I'm going to draw a line from the base up 60, mark off 60, draw a line across, and then I'm going to measure out 100. This is going back to the very, very start. Out 100. So where they cross, and again I'm using my ECC ratio. I multiplied it by 10 just to have a workable measurement. We could have measured 6 and 10. It would have given us the same, but just not as accurate. So that point now is on the ECC line. That is my ECC line. To find the vertex, we draw a line back at 45 degrees, drop it straight down, and that is now my vertex. To draw a portion of the curve, we need to draw in our lastus rectum, which always goes through your focus. Straight line up. And then if you want, you can step out measurements or just pick random points. I'm just going to pick, so we have a point there. We know that that's a point and we have a vertex. So I'll do one in between here. And then I'm going to go I'll just do that much for the video. So given the point, so we're only asked to draw a portion, so we don't have to draw the whole thing. So you extend it back to the lastus rectum. Your focus is always your center. Where it hits, rotate it down. Where they cross the ordinates. There, there, there. We have point P. That's a point. That's a point. And your vertex is a point as well. Lightly join the dots first. One continuous heavy line. And that is a portion of our ellipse. So I'll stop the video there.